And good evening, everyone. Let me get the countdown clock off. Duh. There we go. All right. So we have our live chat here. It is Wednesday, November 12th. The aurora is getting going. We actually see a little bit of a faint red outside. I let Susan check it out for me because I see everything red. So what do you think? She's going out right now to check. There's a little bit of a, we were out just a little bit of red. The data is starting to show that it's shifted more towards the south, the magnetic field, and we're starting to see that influence starting to take hold. Um, she'll be back in just a minute. So we have a lot to talk about, a lot of evolution with the polar vortex, um, a lot of changes going on in the stratosphere. We're going to talk about how there how, how there could be any type of hint out there. Okay, so we're starting to get breaking the clouds. I know that there's other reports of the aurora showing up. It's going to be a little bit more difficult tonight, but if you can stay up to roughly 10 p.m., and I'll show you that, it'll get a little bit better. So about 2 hours in, we'll probably get a little bit better cloud cover. So a lot going on tonight. I was thinking about wearing my Santa hat, but I don't want to jinx anything. I know it's a little early. We're starting to decorate around here already, by the way. We already got 2 trees up, a couple more to go. Because I love you. Because I love you. We're going to have a festive year. Okay, so let's take a look at the data. And let me pull up. Hopefully, I got the right. Here we go. Okay, good deal. Now, I do not play myself off as some sort of expert on solar weather. I got a general idea of it. I learned some of it in college, but if you want to get detailed information, there's nothing better than the Space Weather Prediction Center from NOAA. Okay, you already pay for it, might as well use it. Has amazing data, and you can see the latest observations get updated. We're definitely trending more towards a more of an influence from the aurora. The data coming in is suggesting it's not going to be as strong as what we saw last night, but I think it's still going to be pretty impressive as we move forward over the next couple of hours. So this is the third CME that is impacting the Earth's atmosphere. It's going to still continue to evolve. Now, one of the questions that we're getting quite a bit, does this impact winter weather? Yes and no. Okay. Um, an event by itself, no. Okay. But if you have a lot of them, okay, and in other words, if you have a very active sun, right, that tends to lead to a colder stratospheric environment and a stronger polar vortex. So when we're at our solar peak, this is why I keep an eye on the peaks and the valleys of the solar activity. When you get a peak, you have more of an impact, you get more destruction of ozone in the stratosphere, which leads to cooling in the stratosphere, which leads to the warming in the troposphere, which leads to a stronger polar vortex and also tends to lead to warmer temperatures overall in the tropospheric levels. When you have a warm stratosphere, that means you're allowing ozone to build up. So during 2009, 2010, that winter, we were also having a solar minimum. So that by itself doesn't guarantee an active winter, but the combination of those factors do, right? So this would lead to um, very minimal impact on the evolution of the stratosphere. But a string of these for several months leads to a destruction of the ozone and a reduction of the temperatures in the stratosphere. Now we are moving towards a solar minimum, so we're actually seeing a reduction in activity. So this leads to more buildup of ozone. Now, this factor alone doesn't control the weather. This does not impact. Let's say if someone's trying to run around and say, "Oh, we're having this solar activity and we're going to have a disruption of the polar vortex." No, it doesn't work like that. In fact, if you really want to be technical here, this activity would argue against the polar vortex weakening if it was a 1-to-1 ratio, but it's not a 1-to-1 ratio. You need like a string of these, right, for several months to have an impact. So that won't be an issue. But anyone running around saying like, "Oh, because of this, now we're seeing major disruption," no, you got backwards. So that isn't accurate. So there's a really cool website because you could literally see the changes going on as we watch this whole evolution take place here. Just a lot of great data here. And again, I always say go to the experts, definitely check it out. You got all these dashboards here. So you can literally go to this. If it loads, sometimes it takes a little time. You know why it's taking some time? Because everyone's going to the website. So this is really, I mean, it's great to share this type of science because it's really exciting. And if you ever want to know, hey, why is my phone having a difficult time picking up the internet? What's going on with satellite? What's going on with the radio? What's going on with my cable TV? A lot of it comes down to what is going on with the impacts from solar activity. So here's the dashboard, and you can see tonight's forecast here just got updated. Looks like it's going to be pretty interesting night. It has for both the northern hemisphere and the southern hemisphere. You can watch the planetary index getting updated. So just a lot of great data here. So definitely visit the website. It is swpc.noaa.gov. Hey, with the government opening up apparently in just a couple of hours, that will be updated even more. So that's what's going on. I know there's a lot of questions about whether or not we're going to see any type of impacts from this as far as the weather, as far as the forecast, winter forecast. This directly, no. So I want to make that very, very clear. But yes, there is a cumulative impact. But we're going towards more of a solar minimum. In fact, here, let me see here. One of the here we are. So one of the things I update for premium members every Friday, it's a solar activity. I've been tracking this going all the way back to 2010, doing a lot of updates every Friday. Say, okay, this is where we're at. And so we've been seeing this climb. So during this time period, you're more likely to see a colder stratospheric environment because you're building up the activity, which is reducing the amount of ozone in the atmosphere. Now we've hit that peak, and now we're trending downward. And in fact, now, I'm not guaranteeing anything, but just based on this alone, as we trend into the late 2020s and into the early 2030s, we're going to be heading towards a solar minimum, which means we have a higher chance of building up more ozone in the atmosphere, weaker polar vortexes overall, and you all know what that means. And you line that up with a negative QBO during these time periods, things can get pretty interesting around here. You can end up with another string of very impressive years of winter activity. So the last time we saw winter activity, let's see, we were around here. Remember these years, 2019, 2020, 2021 wasn't too bad. Let's see if we can zone back, all the way back to the year 2000. And you can see the trends here, pretty impressive winters here, pretty impressive winters here leading up to 2020, and then it just kind of died out. So you can see, we had some pretty good winters in the mid 20 teens to late 20 teens. Then it started to increase again 2020 to 2024, not the best winters. Then we hitting our peak, and now we're starting to go on our decline again. Again, it's not a 1-to-1 ratio here, but it kind of gives you an idea of the theme of the atmosphere. Then you combine other factors like the QBO and all that other stuff to work it on. So make sure that we have volume up. We do. Everything looks like it's good as I could have it. Anyone else? Anyone else having any volume issues? Let's let me know. Looks like we're good. Yeah. Okay. Yeah. So like I was saying, where was I? Oh, and here we are with the current ozone right now build up, and you can see it's building up very nicely. We'll have a refresh here. And again, you can see that build up pretty nicely, and that overall trend. So there we have it. Okay, so that's where we are in terms of any type of solar weather or anything of that nature. And again, it's not a 1-to-1. Make sure you understand it's not a 1-to-1 ratio. Okay. It's not, I know there's a lot of people that like to say, hey, we had solar activity and therefore earthquakes and and winter storms. And it doesn't, the atmosphere does not work like that. The atmosphere is not that sensitive. There's always a lag time and you have to build things up. So, um, yeah, I mean, I don't know why some people can't hear. Can you hear okay? I'm hearing you just fine. So okay. I don't know. Turn on the volume. Refresh and reopen it? I don't know. Yeah, apparently everyone else can hear me. So I don't know, Christian. I don't know. Um, but everything else seems fine. So there we go with that aspect. Now let's talk about what's going on with the stratosphere. As you know, we have been getting a lot of excitement from the long range model guidance, right? There's been a lot of growing excitement and a lot of talk about, hey, early December, mid December, late December could be really, really, really active. Yes. Gee, I've only been saying this since what, like May? Um, this winter is going to be very interesting. I am not guaranteeing winter storms, though. I'm not guaranteeing that your backyard will get 3 feet of snow on Christmas Day. I'm not going to do it. Okay. I know a lot of people want to say, is this going to be a blockbuster winter? And understand that there are so many factors that go into that. But let me break down what I'm seeing right now. Okay. When we're looking at our La Nina, again, it's peaking as it should right here. But guess what? The SOI is starting to fall. Gee, I wonder why. It's because contributions are negative. Why is that the case? Because the MJO is in phase 6 and heading towards phase 7 and 8. So, with this setting up here, expect for La Nina to crash and burn in December. So, that's going to mean a buildup of the subtropical jet stream. You're going to see more interaction with the polar jet stream and the subtropical jet stream. Um, you're going to see a little bit less influence from the ridge over the southeast and around the Bahamas. Sea surface temperatures are lining up just right. Again, when people are looking for the blob, so to speak, it's this right here, not this. This is expected. You still have warm here, warm water here. It's this right here that sets the stage for some very interesting active weather for the Mid-Atlantic and New England. The last time we had this showing up here, we had some very active seasons. 2016-17, for example, is a good example of that. 2017-18 was a pretty busy year. Now, what's happening, and we're going to be watching this more. Okay, premium members are going to be bringing this up quite a bit. Okay, you're going to see a lot of discussions about this. The EP flux, we're starting to get a better study. It's taking some time to update here because of the government shutdown, but now that's starting to get revolved tonight. So as a result, we should get better and better data. But you're seeing the vectors here. How do you read this? Okay, so here's the equator, here's the North Pole, right? And so what we're seeing here, and again, this is from the surface, this is the stratosphere. And so what you're seeing here is a transport from the mid latitudes into the higher latitudes of of air masses from the mid latitudes into the northern latitudes, high latitudes at the stratospheric level. So it's kind of like a conveyor belt. So we're seeing that transport of warm air. We could see it in another way, like this. You see this? This doesn't just pop up out of nowhere. This is getting transported from the lower parts of the atmosphere to the higher parts of the atmosphere because the atmosphere is always looking for a balance. So you're getting these conveyor belts popping up all over the place. So as a result, you get this warming starting to show up. This is why the QBO is so important because a negative QBO enhances this transport, a positive QBO reduces this transport. And so what do we have right now is a negative QBO. Now, just for futures, just so you understand, the QBO never stays stagnant, okay? So by this time next winter, we're going to be talking about positive QBO, right? That's this. That's what this signal is here. We saw this signal of a east-based QBO this time. Oh, actually, more like January of this year. We started to see that signal starting to show up, and I said, "Hey, we'll have to watch this for next winter." So this is next winter signal. This is this winter signal. This is going to remain in place and remain the dominant influence all the way through March. Then once we get to like late spring, maybe the summer, it switches to a positive QBO. So then we have to talk about that influence. In the spring and summer months, it doesn't have as much of an influence. Fall and winter months, very strong influence. So that's how this usually plays out. So this year, we just deal with a negative QBO, which means we see that transport of more warm air from the lower troposphere at the mid latitudes to the stratospheric levels in the high latitudes. As a result, more high latitude blocking. And another way to look at it is also the atmospheric angular momentum. Again, model guidance continues to lock in with all the other observations we're talking about. So again, you don't just look at a model and say, oh, well, because XYZ model, which I like the best, is doing this, therefore I'm going to do that. No, you look at the observations first, and then you look at when you study observations, you say, okay, this is where we're at right now. What's the most reasonable conclusion? Well, we have a negative QBO. We've seen the stratospheric warming. We know we have above normal snowfall in Siberia. We know we have very favorable ocean dynamics with the negative IOD, the weakening La Nina, the state of the Atlantic, and more of a supportive reload pattern for the negative NAO. So when I look at the atmospheric angular momentum going to a negative state, and we've seen this before in the summer, and we've seen this in the fall, and now we're seeing this in the winter. What we're seeing here, when you have a negative AAM, atmospheric angular momentum, that builds up high latitude blocking, it increases it. But it's not just the fact it's negative. Look at the fact that it's trending more negative as you go through the month of December. Why is this important to me? Because when I'm thinking about the evolution of the whole weather pattern, and I got it in my brain of saying, okay, everything's starting to evolve here. This is a feedback loop. This is a feedback loop because it's getting more and more negative, which means that the pattern is getting more and more blocky. Why is it setting up a feedback loop? Because of what we're expecting in the stratosphere. Boom. Hello. This is very close to a wind reversal. Now, I've been holding back on this because I have seen plenty of times 15, 20 days out, hey, look, it's going to wind reverse, and then it miles back off. Instead, the models are increasing the support for this, increasing the support for this disruption of the polar vortex. And if this happens, this wind reversal, what you basically do is blow up the polar vortex. You basically smash it and blow it all up, and you got pieces all over the place, which means that your polar and Arctic air can no longer just stay in the Arctic. It drops towards the mid latitudes. China, the United States, Europe, portions of Russia. And then you have to study to see where the high latitude blocking is set up. So, what are we seeing in the model guidance as a result of this? Well, let's see here. Here is, again, we'll just go out to 10 days. Look at that. That's some pretty impressive warming for this time of year. And there's a lot of talk about the fact that this is happening in late November, which is really unusual. Usually you have to wait for like mid-December, maybe for a Christmas present for late December, major stratospheric warming. You've seen this before. This is usually about a month later. So again, we have to see this verified, but boy, oh boy, we're seeing a lot of model data supporting this evolution. If this sets up here, and again, it's supported by the European, the GFS, the Canadian, the ensemble guidance, a lot of model data, a lot. And it's also backed up by the observations that we're seeing right now. If this happens, then you open up the potential for major disruption of the polar vortex, and significant buildup of high latitude blocking. And then if the high latitude blocking lines up, and I'm saying a lot of ifs because, as always with winter, there's always, you gotta always watch out for that little fly in the ointment that just throws things off by just a little bit, which is why you never ever start to say, oh, well, it's going to be like XYZ year, the worst year ever of snowstorms, for example, because you have to understand that those years had perfect alignment, and you don't want to lock yourself in that position. But I I have not personally experienced a major stratospheric warming this early leading into winter. So if you already weaken the polar vortex significantly, and again, this goes all the way into close to Christmas here, all right? Even if you see the polar vortex rebound and trying to get towards normal, right? You got a long way to go. And not only that, but you're still below normal. You still have a weak polar vortex even after this reversal, which opens you up, by the way, with the negative QBO, with all the other factors, with the high latitude blocking, for another disruption that could be just as strong or close to it, right? So you basically kicked the polar vortex in the groin and then expecting it to rebound like as if nothing happened. It doesn't work like that. When you have a disruption like this, it really, really changes the game of what to expect for the winter. We have to wait. We have to wait for verification of this, but then this opens up all sorts of potential factors here, because now you open up the potential for a feedback loop of your negative NAO returning. This does not mean you get negative NAO and a negative EPO every day throughout the entire winter. What it tells me is that, hey, you get one developing, it breaks down, more likely than not, it's going to rebuild just as quickly as it broke down. So it's going to tend to have more staying power. It's going to have a tendency to try to rebuild, and you're more likely to have a trough axis somewhere in here. And so this opens up your positive TNH pattern here. You get a little bit of a weakness here, right, with your ridge. You get this perfect connection here with driving colder air southward, and right around Thanksgiving, it's going to be chilly. Chili turkey. That's the name of the game for Thanksgiving this year. If you're going out to the Macy's Day Parade, uh, probably want to bundle up. It's going to be layers, and feathers. Your turkey's going to need a lot of feathers because it is going to be a chilly one. But I don't think stormy. But we'll see. We'll see how it plays out. We got some time, but definitely chilly, that is for sure. And if you have any friends and family in the Eastern Great Lakes, um, have backup plans because it's going to be one word, one phrase that everyone's going to hate up there, if they unless they really love snow, and that would be lake effect snow. We've already seen some pretty good bands. More is on the way. Okay. So we're seeing a lot of signals here feedback on themselves. And it's going to be very interesting to see this. Now, for the rest of the month, we're going to be moderating because while this is all evolving here, we're going to get more Pacific air masses. Understand that what this signal is basically 50s. That's what I'm seeing in the data. So it's not like we're going to be going up into the 60s or anything. You'll have mostly 50s for the rest of the month until we get towards Thanksgiving, and then everything nosedives. And then we shift back towards a very active pattern. Now, in the meantime, let's take a look and see what our cloud cover is. When you have all these filled in circles here, that means it's cloudy. Do we have any type of hope for better viewing weather? Well, let me see here. Where is that? Oh, here we are. Okay, let me refresh the HRR guidance real fast. Might as well get the latest data that is coming out. And it does not look the best. Perhaps by around 11 p.m. to around midnight, you'll get a little bit more clearing sky. But again, it's not exactly showing up to be the best viewing. If you want to see great viewing, unfortunately, you got to head down towards Virginia, West Virginia, probably the plains. Absolutely, New England. Eh. unless you want to stay up late, maybe that might be a factor here. Yeah, exactly. And a lot of that is driven by the fact that, hey, we have a cold front moving through with some very light precipitation. A lot of this is not reaching the ground, but unfortunately, this isn't the best conditions for viewing an aurora or much of anything else for that matter. And again, you can see on the visible satellite picture, visible slash IR data here, a lot of cloud cover around the region. So sorry about that, but hey, at least someone's seeing it. That's pretty impressive out there. Here's our water vapor satellite picture. Our trough is starting to exit the region. There it is, nice negatively tilted trough. Let me zoom out here. Look at that block. Look at that. That is, again, it's November 12th, and we have one impressive block already showing up. When you get these type of atmospheric blocks, understand it's not just a high pressure here. What you're seeing here is the transport of warmer air from the mid latitudes and tropics up into the polar regions. And that influences everything in terms of the evolution of our stratospheric polar vortex, the tropospheric polar vortex, all of it. And a lot of this is able to feed back on itself because you have warm waters up here that are feeding this ridge that's allowing for that buildup. And then you see that buildup over Greenland and plenty of cold air plummeting. Don't be surprised, okay? When you start to hear about record high temperatures in Alaska, get ready for record low temperatures in the eastern two-thirds of the United States because those record high temperatures are going to be driven by these type of ridges building into Alaska. So again, a lot of evolution here. But the good news is that for the next 90 hours, really into this weekend, no major storms. We have a warm front slash cold front moving through Saturday night into Sunday with a few showers. Again, not looking for any type of heavy rain, maybe a tenth to a quarter of an inch. That's pretty much it as this frontal boundary moves through. As we are in this pattern right now of a lot of changing dynamics in the atmosphere, a lot of changes in tropical forcing, and all of that leads to a very progressive pattern as everything begins to change and evolve. So, again, not looking for any major storms over the next 10 days, not looking for any type of major swings just yet, but definitely a more of a pesky weather pattern with temperatures following between slightly above and slightly below, but no major swings, like nothing historic or anything of that nature. So overall, like a lot of pesky showers. And then as we head towards Saturday night into Sunday, there's our warm front that lifts through, and our cold front follows with a few more showers. Sunday afternoon, evening, temperatures fall, northwesterly wind, scattered cloud cover. So that's all the data I have to show. Now it's time to answer all the questions. So, of course, we always start off with the live chat center here. And I'm seeing a lot of great questions here also in social media land. So we'll get to that in a few minutes. And we're seeing that on Twitch. We got a few viewers as well. So that's good. So let's begin. All right. Let's see. Let me get back to. Here we are. Okay. And Zoe's card is very active because he is outstanding. Um, Wonder if the slight chance of a blockbuster winter is on the table. Um, I gotta be careful with this. How do I answer this? Okay, there is potential for a lot of activity. Um, but I need to see how this plays out. I would just say that this is probably one of our better years going in, right? I certainly would it's certainly more favorable with a major stratospheric warming event now than, let's say, a major cooling event in a powerful polar vortex. So we're certainly moving in that direction. It's actually starting to. I'm getting reports now as far as the breakup of clouds. after 10, unfortunately, around here. So you updated forecast for Thanksgiving. What about Friday to Sunday after Thanksgiving? Give me a little bit of time. I should have more data on that by this weekend. But definitely chilly. I definitely like the idea of chilly. I think that the day before Thanksgiving, which is also a busy travel day, could be rather stormy around here, mostly with rainfall being a threat, I think. But we got some time to keep an eye on that. So some stars in the sky now. Still a lot of cloud cover. Yep. Susan just went out to go check to see if we have any updates. Uh, Too cloudy last night to see anything of the aurora. Here it will be, and here it will be too faint to be seen due to ambient light. Yeah, light pollution is an issue around here. Really, the best place to go to is like Northwest New Jersey, the Poconos, Catskills, North Central Pennsylvania, maybe the Finger Lakes, parts of New England. The further you are away from a solar activity, the better. And it is weaker than what we saw, but there's still potential for it to jump up to G4. That's still in the forecast. So we'll see how that. Subtropical jet stream at 250 millibars and 500 millibars looks a lot more energetic than one would expect for La Nina. This is a very weak La Nina. And honestly, a lot of the evolution right now is more driven by the MJO state than anything else. See anything of interest? Not much. So yeah, I'm not surprised by that at all. Proton storm yesterday due to the flare and CMEs was the first in 20 years and likely added to disruption in all the tech stuff. Oh, absolutely. Notwithstanding a handful of standout events like this week's event and last May's big event, it seems that notwithstanding the active sunspot activity, the actual number of flares and the CMEs that impact the Earth has been a lot lower than the past active. Yeah, we're we're moving towards a more quiet sun, so the impacts are being reduced. We're just noticing it now because a lot of people are love seeing all this activity. My snowblower is sitting in the garage collecting dust. Been 3 years since I used it. Will that change this winter? I would say you have a pretty good chance. And I would definitely check to make sure that if you're running gas or battery, you might want to check to make sure it turns over. Yeah, just to check it. Don't want to have a major snowstorm and it doesn't work. That would stink. Yeah, exactly. Check the battery. Yeah. Let's see here. You can see the flow at 70 millibars and 10 millibars from the tropics to the poles on Earth New School. Yeah. The transport there is definitely locked in. That is part and parcel with a negative QBO. You see that a lot. Just a lot of data really, really, really pointing towards a favorable, interesting winter. Now, you might be saying, Stephen, why are you hesitant then? Why won't you say blockbuster winter? Because I've been doing this for 20 years, okay? And I have seen many a winters line up where it looked like everything was setting up just right, and then all of a sudden you enter a pattern where the polar shortwave is just a little bit too fast, or the subtropical shortwave is too fast, and the storm develops off the coast, or it phases too early and tracks up towards central Pennsylvania, and then redevelops, and Boston gets all the snow. All these other factors. So that's why I will not say yes, definitely blockbuster winter. I want to see First, I want to see one or two wintertime storm tracks to see how they evolve and see how they interact with the high latitude blocking. And then we can start to build up that narrative. But we have to get there first. It's kind of like this, all right? The way I describe it is like this. Let's say you have a baseball team, let's say in New York, perhaps Queens, that goes out and buys a lot of great players. And everything looks like it's perfect. You got the starting staff, you got everything lined up, you got a great outfielder, you got a shortstop that's great, everything's great. And then I don't know, maybe an injury here, maybe a trip there, maybe someone forgets how to throw the baseball properly, and before you know it, you miss the playoffs, right? So, what I'm saying is that the preseason, everything's lined up great, and then you trip over yourself. Eh, right? meteorology is a lot like that. Everything lines up just right, but all you need is one little bit of chaos and it throws everything off. Right now, I'm not seeing that, but I'm just explaining why I don't go out of my way and saying blockbuster winter, worst winter of all time, worst winter storm, blah blah blah. Unless I want to scare you and then hype things up and have you follow me, and then have YouTube and whatnot present show me all over the place because I'm trying to scare you and fear bait. Then yeah, I do that, but I don't. So as always, just a little note: like, share, subscribe. Check out all my social media on Twitch, YouTube, X, Facebook, and let your friends and family know where you get the best weather data in the world for the Northern Mid Atlantic. Okay, so my favorite misuse of models is when models is cited and the initial model zero out doesn't set up with the actual observations. Yeah, that's usually a big warning sign. Let's see here. 70 millibar vortex seems to have two distinct centers of circulation, a stronger one towards Siberia and weaker one towards North America. Yeah, I think that's going to be a theme for a lot of this winter, to be honest with you. I think we're going to see a lot of split polar vortexes. Continent helps the snow in Canada and helps keep the cold air for the season. Yeah, we're definitely seeing a nice rebound in the snowpack. That is for sure in Canada. Steve, are you familiar with the Kyle model, which shows the NAO, PNA, and AO charts? The Kyle model? How many models are? Look, no, I've never heard of the Kyle model. Or I just keep it simple, man. I really do keep it simple. It's not so much about the models. I like using the European model. Why do I like using the European model? Because for literally 15 years running, it has been the statistically best model to use. So it's kind of like, you want to use the most reliable data, but then you don't lean on that data. You take a look at it and say, okay, where could it go wrong? What am I seeing here? And how does this match up with the observations? Um, the GFS, I bag on it a lot because I'm ticked off because I pay for it with my taxes. And it not only has it been last, but it gets worse with the upgrades. So it's annoying to me. But no, I never heard of the Kyle model. That sounds like something out of South Park. Not going to lie, you've caught my intrigue with Miller A mentioned this week. Ah, yes. If the NA if the La Nina collapses and if we do see warm water pop up in January and February in Nino 4, we have to at least consider putting on the Miller A type storm setup. We have to at least consider it. I'm not guaranteeing it. I'm not saying it's going to happen, but it's going to have to. If we see those observations, it is a conversation that we're going to have to have. Toronto Blue Jays game 6 and 7 this year. Perfect example of table setting and missing. I mean, okay, I'll check it out. I don't know. I don't know. Sitting outside waiting for the clouds to break up. Uh, yeah, right. I mean, I'll have to check it out after the feed. We'll take a look at it. But I mean, the theme is the theme. I don't know. Let's take a look. Let's see if we see anything of interest here. What is it based off of? So I'm just loading it right now. I'm taking a look before because I don't want to put it on and then it's like, so that's not reliable. So what is it based off of? Load pattern shown through positive fifth and L. Values are arbitrary, so don't pay attention to the values, just the signs. Well, no. Black line shows 90-day AL activity. Are the four ensemble models. Well, what are the ensembles? I'm not seeing. There needs to be more description on this. I need to know what the ensembles are, what the updates are with them, and the average. So it's kind of lacking data. It looks like it's somewhat of the CFS. I mean, really, you could probably much find it everywhere. Would you say that you say that considering the data that this has a good chance of a white Christmas compared to a normal 5%? Um, oh boy. Um, right now, again, it's November 12th. We'll talk about this again December 12th. Right now, I'll bump it up to 6%. I've been burnt on this too much to say, oh yeah, White Christmas. Um, and I'm a fan of White Christmas. I just been through this for too long to know better, to get super excited. Um, I would say we'll go 6% for now. We'll raise it a percent, and then we'll talk after Thanksgiving. See what we see, right? And then we'll go from there. Because all I need is like, oh yeah, it's cold. It's cold and dry. We get a flurry. You know what I mean? So that'd be my luck. Only reason is that I've seen other Mets use it in the videos. Yeah, the whole thing is that I took a look at the website. I don't see any. Where do you get the model data from? I'll take a look, see if there's a key or something that I'm missing. But you can't tell me he just created a model data on his own, so it must be like some sort of average. How about I double down and say BDB2? Oh, Boxer Day. No, just want light snow on the ground for Christmas Eve and day to make it festive. The heavy stuff could wait until a day or two after. When was the last white Christmas? Actually, we had snow last year. Didn't we have snow last year? Yeah, we had snow on the ground. So that could be considered snowing on Christmas Day. I think we had snow. Yeah, there was snow on the ground. I think last year. Yeah, yeah, absolutely. Yeah, last year. There we go. So let's see what we got here in social media land. See if we have. We'll check out YouTube first. Oh yeah, I can see that. Oh sweet, Oswego. I went to Oswego. Yes, awesome. Oh yeah, here we go. Trip up to SUNY Oswego yesterday was definitely interesting. Persistent lake effect snow band dropped 10 inches over Fulton. Oh, nice. Meanwhile, the campus barely 1 to 2. That happens a lot, and trust me, you want to be thankful for that because yeah. See, here's the thing. Here's what they don't tell you. All the other students, when it snows like that, are going to be off. You, on the other hand, will have, well, especially if Valentine was still there, um, you would have uh, at least 2 or 3 reports. You'd have to analyze it, break everything down. There is no snow days. Snow days is a work day. Where snow days are a lab day. There we go. But it's fun. It's a blast. You'll learn a lot there. And the one thing I love about Oswego that I went to a variety of different schools was just the one-on-one interaction with the professors. Because the way I see it, if I'm going to spend 60, 80, $100,000 on education, I better be talking to the professor and not some kid who just graduated 4 years ahead of me. That's just how I see it. So it's a great environment. Uh, how do you think Sunday night, Monday's lake effect is going to be a bit far out? The preliminary data shows pretty good alignment on Lake Ontario and Lake Erie. So it has the potential there to be pretty good. But we need a little bit more data on the instability. Da, 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 da. So someone had more rain. Triple to speed yesterday. Da, da, da. Let's see here. A lot of great stuff. I'm trying to get the overall theme here from YouTube. Will the interaction between polar jet and subtropical jet lead to severe weather? Uh, not all right. Not severe thunderstorms, unless you're in the southeast. Then yeah, you know. If you get phasing between the two jet streams, it certainly increases the potential for more dynamic storms. Let's see here. It's certainly looking chilly for December, but Again, I want to see how everything plays out, but certainly leaning towards that. Thanksgiving right now is looking like 40s with windy conditions. Well, the reason why the QBO is saying west descending is because we're starting to see the wind starting to descend at 1 millibar and 5 millibars, which is totally 100% normal. It'd be incredibly unnormal. It'd be very, very strange if we saw a persistent negative QBO all the way in the top of the stratosphere while this is happening in the mid levels of the stratosphere, because the QBO doesn't work like that. It's constantly rotating. So, what happens is that the upper part of the stratosphere, right, it's at one phase. Let's say right now it's positive. And what happens over several months is that descends down into the lower parts of the stratosphere. And the part of the stratosphere that we have right now, easterly, that descends down into the troposphere and then dissipates. And then the other wave marches down. So it's constantly doing that, right? It's constantly transporting down. So the positive phase that is setting up for next spring/summer into next winter is starting to form now in the highest part of the stratosphere. Okay, and then that grows and extends and works its way down while we get all the impacts of the negative QBO right now. Then while the positive QBO next year starts to take hold, the negative phase for the next year starts to show up. And typically we see that. Now you can get disruptions via volcanoes or unusual ionospheric interaction, but that's usually how it works out. Let's see here. Thank you about the flurry video. I appreciate it. I noticed both the EPS and the GEFS don't see cold shots that the negative NAO reinforces. For example, next week's cool shot was not seen by either model as recently as a couple days ago. It seems to underdoing the negative NAO influence. It depends on how you read the model guidance. I never take verbatim any of the anomaly readings, but what I want to do when I see that is like, okay, what air masses am I interacting with here? This pattern, this transition, even with the negative NAO, is more of a Pacific polar interaction, which is why I like temperatures generally in the 50s. I'd stay away from anything like the mid 60s or anything like that, unless like you have a strong cold front coming through and you get like a bump for a day and then it falls back down. But even that, I'd limit that to the Philadelphia metro. This is why you just don't take model guidance and take it, rinse, repeat. You don't do that. You take it and then you look at the surrounding environment and you put that together with what you're dealing with right now, right? So, again, models are just tools, they're not crystal balls. Uh, yeah, the MJO could get stuck, but I wouldn't. I'm not going to forecast that until I actually see some supporting data for that. Uh, the possibility's there for a major East Coast storm, but that's all I'll say on it. Yep. Definitely long range model guys is bullish. Meteorology is a lot like the New York Mets, huh? Yep. Your AI saw the cool shot. Yeah, they did. Yeah, the AI guidance has actually done pretty well, to be honest with you, of late. Yeah, that is true. Anyone who celebrated Christmas on January 7th, the Eastern Orthodox have had a white Christmas for 4 or 5 years over the past 8. That is true. Let's see here. All right, so really good question about a son studying meteorology. And this is true of any college. Here's my advice. One, it's okay that you fail. And what I mean by that is that you're going to be running into, unlike all your friends, unless you just have friends within the meteorology community, which is good too. But let's say if you have a roommate, you will be dealing with in your freshman year, at least I did, physics, chemistry, calculus, possibly calculus 2, depending on where you are in high school right now. Um, calculus 3 usually is sophomore year or the second year freshman year. It was the second year freshman year for me, but anyway. Um, and then you got your meteorology classes. You got your dynamic class, you got your synoptic class, you got your climate class, you got your, depending on the way that they set up the structure, you may have geology as well. These are all highly intensive classes, not to mention the fact you got your general education classes that they force on you with some ridiculous nonsense. And then you have social things, new friends, new family, a lot of things taking. So you're going to get overwhelmed, and it's completely normal. Use the study guides, talk to your professors, get tutoring when you need it, but also give yourself a break. Focus on your work and give yourself that either Friday night or Saturday night to blow off steam. You have to, or you will go insane, or possibly forget how to write your name on a final. Been there, done it. Um, so you want to be able to just take a break, but you also have to give yourself latitude, right? To have a failed test, to have just 1 week where things don't work out. You may not understand a concept. You may even fail a class, which may be indication that maybe you took on too much. These are all things that you're going to have to grow and learn. You're not going to know it right off the bat. You might struggle in a concept. It's completely normal. You're not the first nor the last person to have these issues. You may do really, really well. And then sophomore year, you run into a roadblock. Maybe it's calculus 3, or maybe it's the way that dynamics are taught. Okay, but this is an important time where you have to learn to take failure and learn how to grow from it and make yourself stronger. Okay, so that's my suggestion for you. Study hard, focus. I'm not a big fan of Greek stuff, to be honest with you, because at least from my experience, it was a lot of wasted time. All right. Anytime that takes away where you're getting up on a Tuesday at 2 a.m. to do some sort of rush thing is a waste of time and money, by the way. So I'm not a big fan of that type of stuff, especially in this type of intensive education. But give yourself that room to grow and embrace the challenges in front of you, and you'll be okay, right? And remember, I always say this: a C in a meteorology course is an A in any other course. Okay, especially when you have all those type of high intensive math classes where you have to memorize all these equations and understand what all these symbols and stuff means, and then you just walk in, and then your roommate maybe is taking, I don't know, English lit, and they're complaining that they have to read a book, right? Like make a book report. So give yourself that latitude, right? You'll get through it. Everyone does. Everyone at least fails at least one class, but you'll be okay. Let's see here. Yeah, the winds are definitely getting a little bit gustier. That is true. It's that time of year where lake effect snow impacts football games. Yep, I agree with that. Yes, we had a snow squall around 10 a.m. on Christmas Eve. I knew it. Yes, yes. I think we had 1 to 3 inches or something. Odds are growing of a SSW event, strong stratospheric warming, around Thanksgiving with complete wind reversal. Possible, yes. That's definitely increasing in terms of the potential out there. Anything on Facebook or X? Is this your full-time job? One of them. Yeah. Yeah, the weather doesn't stop. I got other couple of gigs too as well. Here's the thing, ladies and gentlemen, in this world, I'm sure many of you know, uh, you can't have one income source. Gotta have multiple. Keep on playing the game. Hustle. Let's see here. Let's see here. Maybe things will align so the Jets win tomorrow night. Hey, maybe. Yeah, the Jets have been impressing me the past couple of games. I'm not a Jets fan, but hey, moving in the right direction. Nobody can predict a storm track. Well, I mean, not this far out. I appreciate your lack to commit on a big winter. It's all wait and see and hope. Yeah, I mean, here's the thing. I do not want to go and saying that, hey, you're going to have a blockbuster winter puts in a lot of expectations that businesses may jump on that would be inappropriate, right? And I don't want to do that. I would definitely say that a lot of favorable data pointing in the right direction. But the reason why, like for example, some people say, "Oh, it's like 95, 96." Understand, the winter of 95, 96 was, yeah, blockbuster. It was also literally perfect, right? So my expectation of that type of winter, which would be amazing, for me to run around and make that type of comparison would be completely irresponsible because I know how difficult it is to pull it off. But I will say, going into the winter, I like this data a lot better as a snow lover. I mean, look, I have killed my snow bias, right? Um, Out of force in order to become a better meteorologist. But the inner 5 year old in me looks at this data and just grins, right? I'm not going to lie about that. But the adult in me also says, okay, it's all moving in the right direction. Let's see how it all comes together, right? So we have good cookie dough. Let's see if, when we put it in the oven, that we don't get any burnt cookies. Okay, that's basically how I'm trying to play it. Try to work this out. My favorite class in college was synoptic meteorology because, um, and you'll love this. We'd have to like create a, excuse me, we had to create a forecast, and then we'd have to go up and present it, and then the professor would just rip it apart, like you're missing this, and you didn't include that, and you didn't look at the right jet streak at this level. You forgot to look at the vertical velocity on this model guidance. Why are you using the NAM model guidance at this time period? Stuff like that, that as a young meteorologist, you don't realize. And when you're trying to explain it, you may not understand. And also the little things. I don't know if they still do this, but one of the things I used to love to do was we'd get the observations and we'd have to draw in where the pressure lines were and actually make a surface map on pencil. So there was no, just pull up a model and this and that. And again, back then when I went to Oswego, and this is the late 90s, we had GARP. So everyone would fight to get on a GARP machine because they were limited. So that was hard to do. You'd have to set a time to actually be able to go look at it so you could create your forecast, because you had to make a forecast every day on top of all the other work that you're doing, right? So you had to go do that. So you had to figure out when to get GARP. You had the European model data was just a little website with some very, very poor graphics, hard to see. Then you had the MERF, where all you had was what was called, like, up to about day 5, it was kind of reasonable, and then it'll start spitting out hurricanes all over the place. So it created what we call a Murphicane all over the place. Like, it's the middle of December, also there's a hurricane sitting over New York City. They're like, okay, throw that out. So the GFS history of being a little wacky, well, it's because its DNA is from the MRF. And the MRF was god awful, but nowhere near as bad as the NGM, which was horrendously awful, right, to use. So it's just a whole lot of memories. But I used to love synoptic class. Um, I enjoyed physics class because, again, it was intro to physics and it was easy for me. But I was in there with a lot of like other students. So you had like a lot of students that needed tutoring. So I would do tutoring. So that was always fun. They took all the meteorology students out of the curve though, because we kept on blowing the curve and failing, causing everyone else to fail. So with us out of it, your 75 would be an A, but with us in it, your 75 would be a D or an E. So they had to take us out of the weight because we were causing too many people to fail. Not just me, all the meteorology or physics, the physics, meteorology, anything science based, we just nuked it. Yeah, we nuked the curve. It wouldn't even be fair. So the parents are like, I can't have everyone fail this class. You guys are going to have to be at a different level. Let's see here. Isn't that long ago that we had a setup for a really nice winter that got completely blown up because of very first shortwave for the first storm had timing off by less than 6 hours, and it resulted in complete consolidation of the polar vortex, the Arctic jets, and left us with a warm Pacific air mass. Exactly. Exactly. I don't think that's going to happen this year, but good example. It's already 9 o'clock. What do you know? We had a fun chat, and we haven't don't even have a winter storm yet. So
No, we got a lot of people already asking about Thanksgiving and Christmas.
yes, indeed. And I will say this again for premium members, I will have the update every day on a little bar on the top here. Actually, let me show you guys what it looks like. A little bit of advertisement. Let me pull this up. Okay, so on the premium dashboard, right here is the Thanksgiving update. As you can see, I made one this afternoon. And again, if you are a landscaping guy, this is a quick look, see if we have any threat for any type of rainfall or snow, and all the discussions here. So that's what you get in the premium dashboard, aside from my lovely thoughts as well and my interaction. So that is it for tonight. I think we covered a lot of information. Outstanding job on both YouTube and on Twitch, and of course at NYNJPA Weather. It's just outstanding. I cannot say enough how amazing this is to be able to have these conversations with you and share all this information. Thank you as always. We'll continue to watch this evolving weather pattern. And in the meantime, stay safe out there.